So for this section, solving trig equations, which is section 7.7, we have our learning target. I can solve trig equations involving a single function. Now I want to give you a couple of steps that you will have to remember in order to solve some of these. In particular, we'll call these the steps to success criteria. There are only two of them, and the first one that you want to do on each of these questions is to isolate the trig function. That is, get the trig function by itself. If you have a sine or a cosecant or a tangent or a cosine or whatever, get that trig function by itself first before you evaluate. And then your unit circle is going to be very important, something that looks like this that we can refer to once we get that trig function isolated. Now the first thing that I want to show you, just as an example to kind of think of where we're going with this, is to think of a real simple function. Let's say sine of theta is equal to 1/2. Now I want you to be able to think about this in two different ways, just so that you understand where we're going. And the first way, the less common way in order to solve these, is to think of the sine wave. And obviously sine of 0 is 0, so this is going to start at the origin. And this wave is going to continue infinitely in both directions. And so if I think about this, the amplitude of sine is 1, so this goes up to 1 and down to -1. So I want to know, where is my function equal to 1/2? And if I think of this horizontal line that goes through 1/2, you might note that this goes through the wave infinitely many times. In particular, I'm looking for these x values for which the y values are 1/2. And notice it crosses through that dotted line twice as I go through my first part of the wave. There are no positive 1/2 values down here, but I have two more positive 1/2 values up here. So each one on quadrants 1 and 2, I think the y values are going to be equal to 1/2. Okay? If I kind of think about this in two different versions, my or is going to be thinking of the unit circle. On the unit circle, where is sine? Remember, sine is the y value equal to 1/2. Well, if I think of my y value is going to be this first number here, okay, on the outside, this is going to be the 1/2 line, right? And so I think of these angles. Well, this angle right here is going to be pi over 6 radians. And this is going to be pi over 6 radians from pi, or subtracted from pi. So let's call this angle 5 pi over 6. So pi over 6 and 5 pi over 6 would be my two solutions for that. So now if we think about how are we going to be able to write this? Okay, so I want to give you something called the general solutions, which I think of as all of the solutions. We've noted two of them on the unit circle as pi over 6 and 5 pi over 6. And I want you to note that this is pi over 6. I could go around the circle again and get this angle. I could go around the circle again and get this angle. I could go around the circle 10 times or 100 times and get the same number, which is going to give me the same y value of 1/2. So how can I write that as some version of pi over 6? I can add to it 2 pi. I can add to it 4 pi, or 6 pi, or 8 pi. Or I can go around this 100 times, and that would be 200 pi. What we want to do is add to it 2 pi k. And I'm going to say here in this case, where k is an integer, right? And the same is true for 5 pi over 6. If I have this angle, I can go around the circle once, I can go around the circle twice, and get these numbers over and over and over again, so I can add to it some version of 2 pi, in the general case of 2 pi k. Now for the problems that I'm going to teach you today, we're not necessarily worried about this 2 pi k business. I just want you to note that it is going to come up. You might see it in the back of the book or in other resources that you're using for your learning. But I want to say that we are just concerned about the restricted solutions. In the case of our solutions of pi over 6 and 5 pi over 6, I'm just going to restrict all of my solutions for all of my angles to be between 0 and 2 pi. So really the question is, where are the angles just in general on the unit circle that satisfy my equation? In this case, pi over 6 and 5 pi over 6. I mean, I could continually go around the circle to get more solutions, but if we can just restrict our solutions to be between 0 and 2 pi. That's how we're going to stick for today's lesson. So let's do a few examples and see how these work. So for example 1, if we have something that looks like this, negative 2 times cosine of theta is equal to root 3. We know from the first step of the steps to success criteria that I want to get the trig function by itself. So if we divide both sides by negative 2, negative root 3 over 2. We let our unit circle do all the work. And remember, we are in the domain from 0 to 2 pi, so I'm looking for just the numbers that are just on the unit circle. Now remember what cosine is referring to. Cosine is referring to an x value. So remember, this is the x value, and I'm solving for theta. That has an angle that has an x value of negative root 3 over 2. So remember, my x values are left and right. And so I have a negative root 3 over 2 x value here. And if I flip that down, I also have a negative root 3 over 2 x value here. So my two angles are 5 pi over 6 and 7 pi over 6. We want to put our answers in the form of a set, because anytime I have more than one solution to a problem, it is going to be in the form of a set. Let's try that again. The problem is done. Let's go to example 2. We have 5 examples today. Let's say we have something like sine of beta is equal to negative 1 minus sine of beta. No worries about beta. That's just another variable that we're going to use. Let's get the trig function by itself. We're going to add sine of beta to both sides like this. And I'm going to now say that 2 sine of beta is equal to negative 1. Get the trig function by itself and divide both sides by 2. Sine of beta is equal to negative 1/2. And once again, we come back to the unit circle. Sine is the y value, and I'm looking for the y values that have a negative 1/2. I find one here that's straight down. Negative 1/2 is going to be 7 pi over 6. And here's another one when I flip over here into quadrant 4. Negative 1/2 is the y value, which is going to be 11 pi over 6. So therefore, my angle beta is going to be equal to 7 pi over 6 and 11 pi over 6. And those are within our restricted domain of 0 to 2 pi. Let's look at a couple different ones that have sort of a twist. If I look at something like this, 4 cosine squared of theta is equal to 1. A little bit of a different question here where I have a squared, but let's first divide both sides by 4. I'm going to say that cosine squared of theta is equal to 1/4. And then to isolate the trig function, I have my squared here. We can just go ahead and take the square root. So I'm going to say that cosine is equal to the square root of 1/4 is 1/2. When you take the square root, we do want to write plus or minus. So now that I'm looking for all of my angles such that the x values are positive or negative 1/2. So in this case, I'm going to need 4 solutions for this. Let's go back to the circle and let the circle do all the work. Cosine is the x values. I'm looking for all the angles that have an x value of 1/2. I found one here. That's at pi over 3. I could do negative 1/2, which is 2 pi over 3. I have a negative 1/2 straight down, which is 4 pi over 3, and a negative positive 1/2 straight down, which is 5 pi over 3. So I have 4 solutions for this case, and we're just going to list them as pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Essentially what you want to remember when you have a plus or a minus because you had a squared in your equation, you're going to do 4 solutions for that equation. Let's look at another one that has a little bit of a twist that might come up from time to time. Example 4 is this. 2 cosine of 2x is equal to root 2. A 2x that's inside the parentheses. I want to hold on to that until after I use the unit circle because my cosine is on the outside of that argument 2x. Let's first get the cosine by itself by dividing both sides by 2. And now since I have my argument within the parentheses, within the function, I'm going to use the unit circle right away. And I'm going to find all the values that have 2x equal to this. Now cosine is the x value, and my x value is root 2 over 2. Back to the unit circle, I have an x value of root 2 over 2, which is here. That's pi over 4. And straight down, a positive root 2 over 2 is 7 pi over 4. So essentially, I have 2x that's equal to both of these values, pi over 4 and 7 pi over 4. And now simply, we just have to solve for x by dividing both sides by 2 to cancel this out, divide both sides by 2. So my two solutions for x are pi over 4 divided by 2. Could I just double the bottom? Or I could think of this as pi over 4 times 1 over 2. So let's call that pi over 8. And same thing here, if I just double the bottom, we're going to go ahead and call this 7 pi over 8. So my two solutions here are going to be pi over 8 and 7 pi over 8. Just remember to hold on to your argument until after you use the unit circle to eliminate the trig function. And my last example for this lesson. If I have 3 cosecant of theta plus 5 is equal to negative 1. Simple solution that we're just going to, again, isolate the trig function. I'm going to subtract 5 from both sides like this. Divide both sides by negative 3. And we see that cosecant of theta is equal to negative 2. Now, we don't really directly know where the cosecant is located on the unit circle. So what I suggest is use an identity to swap this out for something that you do know. I do know that the reciprocal of cosecant is sine. So essentially what I'm doing is taking the reciprocal of both sides. And so what I have here now is that sine of theta is equal to negative 1/2. And again, I have my trig function isolated, so I can use my circle to let the circle do all the work. Sine is the y value, and I have a y value of negative 1/2 straight down in quadrants 3 and 4. And so it looks like it's 7 pi over 6 and 11 pi over 6. Final answers. Essentially what we need on all of these solutions is plus 2 pi k. We don't need that in the restricted domain, but it will come up from time to time if they ask you to find, say they ask you to find 4 solutions or 6 solutions. I could just continue going around the circle to find the number of solutions that I need.